but today we're talking about properties of parabolas, 5-2. You'll notice up in the learning goals, finding the minimum or maximum of the quadratic function, but then we're going to be graphing those using vertex form today. And we've done a little graphing already this year. We've talked about a lot of the stuff we're going to explore here at the beginning, so it'll be a quick review, but it's definitely notes you want to get down, because as we progress through this chapter, we do a lot of different things. I mean, we do graphing, yesterday we did some simplifying the quadratics. We'll be factoring and doing completing the square and the quadratic formula. So there'll be a lot of things you're doing, a lot of different pieces that you're learning, and the things that seem really easy at the time get kind of lost in the shuffle once you get to the end of the chapter and you have all this mass of material. Bless you. So make sure you're writing things down and leaving yourself little notes. If there's something that we cover, then you're like, oh yeah, I'd forgotten that, but I remember now. That was easy. Well, it was so easy that you forgot it, and now you remembered it. So it could be so easy that you're going to forget it again. So write it down. Try to have it set in your memory and put a little star by it so you remember to study that. Okay? Okay. Need you to answer those questions right there. Okay. You work with your partner. You probably don't need a book for them, but if you need a book, you can grab it. You get about 3 or 4 minutes there. Okay. Draw a picture to define the vertex and axis of symmetry. So like I said, we've talked about this a bit, but if I have, let's use an actual pencil here. If I have an XY axis, okay, and I am going to put in a parabola there. Okay, so let's do this so we actually a few different things. So there's my parabola. This piece right here at the very bottom or at the very top is actually called our vertex. Okay? And there's a mirror that runs right through the vertex, this line right here, this mirrored line. This is called your axis of symmetry. And we talked about these a bit this year. You've studied them in Algebra 1, but there's your vertex, there's your axis of symmetry. Okay? Now in this case, the vertex is actually called this is a minimum value. Why is that a minimum? Yeah?
Because it's at the bottom, because the parabola is facing up, so there can't be a maximum because those go on forever.
Yeah, that's a good point. The parabola is going upward. It can't be a maximum. It goes on forever. You can have a minimum. It's at the very bottom. So I want you to sketch a quick parabola of what a maximum would look like. Just a quick picture. Okay, so maybe your picture looks like this, maybe not. But in this case, your maximum would be the vertex when the parabola is opening downward. So if that's our vertex again, that is the maximum. All right, once again, there's some key pieces. The vertex and the max and min is a key piece. This line, the axis of symmetry, is a key piece. It's always in the form of x equals something. So that's our axis of symmetry. And then the other points that are important for you to write down, or at least make note of, is this guy right here. These two guys. What are these called?
X-intercepts.
Good, those are your x-intercepts. Okay, and then this point right here, which is called?
Y-intercept.
Good, that's our y-intercept. All right, so all key pieces that you may want to make note of there. All right. Any questions there? Think we got it? Okay, that's a quick review. So if you need a better picture, page 2, I know that some of you looked in your books, but you have page 205 that has a picture there. What I like about page 205, it actually gives you this thing right here. x squared, or y equals negative x squared and y equals x squared. And you'll notice the value in front of each of those. In front of negative x squared, it's negative 1. In front of positive x squared, it's positive 1. I want you to tell your neighbor how A affects our graph. What does A do? How it's affecting these graphs. Okay, how does A affect our graph? Go ahead, Alec.
It affects it because it either moves it, it makes it wider or skinnier, and it opens up or down.
Good, it opens up or down in this case. It also makes it wider or skinnier, but if A is positive, remember if it's a positive A value, then it opens up. It's a smiley face. If it's negative, it's a frowny face. It opens down. Don't be so negative about it. All right? So positive A opens up, negative A opens down. It also, as Alec pointed out, affects the width of your parabola. So if I take a look at page 206, you guys don't have to use your book, but you can look up here, or you could turn to 206 if you have your book. Okay, questions 4 and 5 says all parabolas have the same basic shape. The width of the parabola changes as the coefficient of the quadratic changes. Identify the coefficient of each quadratic, and how does increasing the value of the coefficient affect the graph of the function. Right, now I want you to take a look at number 4A and B. Answer those two questions with your neighbor there. Okay, can I get your attention back up here? What is the term coefficient? What does that mean? What's coefficient mean? Hannah?
The number before the variable.
Good, it's the number before your variable. So in this case we have 2. We have 1/2. What's it here? 1. Yeah, that's a 1. Okay, so identifying those coefficients, 2, 1/2, and 1, right? How does increasing the value of the coefficient affect our graph? Well, if you think of our parent function, the parent function's going to be the yellow one here, y equals x squared. Okay, that is, from that function, everything else it comes from that. We either shift it up or down, or shift it left or right, or flip it, or make it wider or narrower. Okay, so right now we have x squared. Think of your 2, the A term. Think of A as like means accelerator. How many are going to be driving soon? Some of you. How many of you want to drive soon? Okay, some of you don't want to drive maybe. Okay. Well, if you think of A as your accelerator, if the average speed or the normal speed is 1, that's the parent function. Like if your parents are like, dude, you can only drive 1 mile an hour. Okay? All right? And you're going, well, I've got to get to infinity and beyond, man. So how am I going to do that if I'm only going 1 mile an hour? And they're like, I don't know. Okay, and then maybe you're like hanging out with your grandparents, like, you're going a little too fast for me. We're going to decrease this about to like 1/2 mile an hour. You're like, whoa, Grandma, I've got to get to infinity and beyond, and it's going to take me a lot longer if I'm going 1/2 mile an hour. Okay? Everyone get that? This is your speed limit. Your parent's speed limit, your grandparent's speed limit, right here. And then maybe you have, I don't know, an Uncle Rico. Okay? Uncle Rico's like, dude, crank it up. We're cruising, man. You're going 2 miles an hour. You're like, Uncle Rico, I'm going to get to infinity much faster cruising with you, man. Okay? You're going much faster. All right? This is your accelerator. We got it? All right. I'm not sure if everyone would relate it like that, but that's accelerator. Okay? And you use cool colors for it. So the further your value is from 0, your graph gets what? Yeah, it starts getting narrow. You're going up faster. The closer your value is to 0, what happens to your graph? It gets wider. Now, how many remember talking about this at the beginning of the week? Does it matter if it's positive or negative? No, it doesn't. So if I have number 5 here, we're not going to actually graph these, but if I take these coefficients, okay, I take y equals negative x squared, and remember negative, there's no value there. That's like having a 1. Okay, y equals negative 1/3 x squared. Okay, and then y equals, go over here, negative 3x squared. Tell your neighbor which one's the widest and which one's the narrowest in terms of those graphs. Okay, let's wrap it up. Which one is the widest? Which one's the widest?
Y equals negative 1/3 x squared.
Good. If we're going widest, y equals negative 1/3 x squared because the negative 1/3 is closest to 0. What's next? We're going widest to narrowest. What goes next?
Negative.
That is really blurry. I don't know that helps. Go ahead, Jaden. Negative x squared, negative 1x squared. So y equals negative x squared. And then obviously the one furthest from 0, negative 3x squared. Always put that y equals. You'll notice I sometimes start to forget that. Get that y equals in there, otherwise you don't have an equation. Any questions on that? So A controls width and up or down, right? Okay. All right. So complete the statement. Make sure it's in your notes. Remember, it may seem easy now. Might not be as easy later in the chapter when you've done all this other stuff and you're like, man, we did that way back in 5.2. And I'm like, yeah, you did. Crazy, right? Okay. Complete that statement, please.
Club and
Nice. I'd be good at that one. See my desk. Okay, complete the statement. As the absolute value of the coefficient of the quadratic increases, the graph of the function becomes narrower. All right. I didn't quite circle it well, but that's okay. All right, I want you guys to take a look at this one. Number 3 on page 205. If you have your book and you want to use that, that's fine. It says, use the graph at the right, give the coordinates of the vertex. Okay. And then what points correspond? So we're going to start getting into graphing these. So take a look at that. Spend a couple minutes on it. Okay, so use the graph at the right, give the coordinates of the vertex, which are, Kaylin, what are the coordinates of the vertex? What? 2, 0. Now I'm using a pen, so don't mess me up. 2, 0. Okay? That's our vertex. All right. What point corresponds to Q prime? Boy, Cody, what do you got? Q. Okay, notice it's a reflection, right? Now, if you remember back to geometry, the properties of reflections, if you're reflecting across the axis of symmetry, which in this case, the axis of symmetry is at x equals 2. Notice I used x equals 2. Not just 2, because x equals 2 is this line. 2 could be any point on that line or any point on the y equals 2 line. So you got to say x equals 2. Okay? So if I'm using the axis of symmetry, x equals 2, and I'm reflecting this point across it, then I need to cross that line of reflection at a right angle. That was something you did in geometry. And then the distance away should be the same. Okay? So this coordinate right here is Q, which is 0, 8. This one? And this one? Well, this is 1, 2. That makes P prime B. Reflect, 1 away. 3, 2. All right. Any questions? So it'd be easy if they just gave us points that we could reflect. That'd make graphing a lot easier.
yeah, that'd be nice of them.
That would be nice. But you know what? They're not going to do that right here. So number 6A, we're going to do this one on our papers. You have some graphs on that on your note page there that you're going to use. It says find the coordinates of the vertex of the equation and the axis of symmetry for this equation. So given this equation, the first thing you always do is find the coordinates of the vertex and axis of symmetry. So you're going to use vertex. You don't have to spell it out every time. You can just use the letter V, Vogel's favorite point, okay, for vertex. List the vertex. And then axis of symmetry, rather than actually spelling out axis of symmetry every time, okay, you could just use AOS. Okay, axis of symmetry. Now, some of you are remembering, some of you are like, I don't know. Anyone know the vertex and axis of symmetry? Huh. Couple of you? Couple of us? Okay, before we get that, since most of us don't know, let's pause right there. We'll come back to that here in a second. And I want you to read this statement. There they are. Hello. I want you to read this statement. This on page 208. Go ahead and read through it. Make sure you understand what it means there. I'll give you a minute. Some of you actually probably spent time reading this. Maybe some of you just sat there and you're like, I'm not going to read that. Now keep in mind, next year the class you take at high school, if you go to Lake Stevens High School, is you can get college credit for that class. Okay? You could be a year or so away, about a year and a half away from actually being enrolled in Everett Community College, those of you who do Running Start. And when you do that and you have your textbooks, they're going to ask you to read. Like, you won't have an option because you'll be doing the work at home. I guess you do have an option, but you don't like the other part of the option. Okay? So reading this, if this is tough, you kind of have some mathese here, just take it sentence by sentence. Properties of parabola written in vertex form. Okay. An equation of the form y equals a times quantity x minus h quantity squared plus k is a function written in vertex form. So what is vertex form? Well, dude, that's what that just said. Now, some of you remember that. Those of you that raised your hand just a minute ago, about 5 or 6 of you, how many of you thought that was vertex form? How many of you are using HK there? How many kind of recall HK now? Okay, I know it was like a long month ago or so that we did it. But, okay, the vertex form gives you the following information. So you wrote down vertex form. It tells you the vertex. HK, who cares, right? HK, who cares? And the axis of symmetry is the line x equals h. So the vertex is HK. The axis of symmetry is at x equals h. So this value right here is always the thing that goes right here in your equation for axis of symmetry. Those two things are always the same. The parabola opens up when a is positive, opens down when a is negative. We already talked about that today, right? And then this starts going absolute value. If the absolute value, what's absolute value mean? Yeah. Good. If the distance from 0 is less than 1, the graph will be wider than y equals x squared, which is our parent function. So in other words, if it's closer to 0, dude, your graph's wide. If it's further from 0, your graph's narrow. If it's greater than 1, the further away from 0 it gets, the narrower it gets. We talked about that. So really the piece that's new that we haven't talked about yet today is this. And we've talked about that before. This h value, as long as this says 1x minus h, whatever number is here is the h of your vertex. Remember, it has to say 1x. We'll talk more about that here in a minute. And then whatever's back here, if it's positive, that's a positive number. If it's negative, it's a negative number. That's your vertex. Okay. Any questions there? Well, let's go back to this one now. We are identifying our vertex and our axis of symmetry. So the vertex in this, go ahead and tell your neighbor what the vertex is.
Would be -5.
What do you got?
-5, -1.
Okay, I'll agree with the k is -1. Yeah?
It doesn't have to be 5 because it's like -5, so it'd be like -5. So
Yeah,
positive.
It's actually +5. Now, you guys remember, at your vertex form, and it may be something you write on top of your paper each time you're graphing. That's our vertex form. So it's 1x minus. So if that's a minus, then this number right back here is your h. Okay? So it's whatever makes this piece equal 0. So what does x have to be to make that 0? 5. So x is 5. That's your h value. Okay? Does that make sense? So if I were to step out of this problem for a minute and I were to give you, say, y equals 2 times x minus, or actually let's go 4x minus 3 squared plus 7, and I want to find my h value. It's what makes this thing 0. It's not just +3 here, right? The best way to really think about your h value is saying what makes the thing in my parentheses equal 0. So in this case, we set it equals 0. We add 3 to both sides, and then we divide by 4. My h value would be 3 fourths. That's so bad. Here, let's write it like that. 3 fourths. What's my k value? 7. It doesn't change. Okay? It'd be a good note to make to yourself. They're not always going to stay this easy, where it's just as easy as saying, well, it's 5. Okay? What's the axis of symmetry?
X equals 5.
X equals whatever's right here. Always the same. These two things, always the same. Okay? So what we're going to do is we're going to plot it. 5, negative 1. We'll go to 5. We go down 1. Got it right there. Okay? And then from there, we need to calculate. I need to see at least 5 points when you're graphing. All right? Now, some of you are like, you know what's next. You're like, oh, man. I do an XY table like this, where I put the rule in the middle. And the rule is this thing right here. It's this chunk on the other side of the y equals. So the negative 2 times x minus 5 squared minus 1. That's the rule. That way when I have an input, I can put something in for x and then chug through here and get an output. Called plug and chug there. All right. I know. So we got 5, negative 1. We know that this graph, is it opening up or down? Up. Down because a is negative. Yeah. So this graph is going to go downward. I know the vertex is at 5, negative 1. I know one of my values. I always put my vertex in the middle, put a v by it. I'm not going to show any work because I already know it's there. Okay? But I want to at least pick some other values. And remember, since that's my vertex, this line right here at x equaling 5 is my axis of symmetry. Okay, so everything's going to reflect. So if I can just find 2 more points on one of my sides, then I can just reflect them over. So really I only have to calculate 2 points. So I'm going to go with 4. Why? Because it's the next number over, and it's a whole number. It's easier than 6. So I'm going to go with 4. Negative 2, I'm going to put 4 in for x. So x became 4 minus 1. All right, so I'm just going to do the math now that I have it here. I'm going to go 4. Remember, do parentheses and then square and then multiply. Right, order operations, parentheses, exponents, multiplication. Okay, 4 minus 5 is? Negative 1 squared.
1.
A negative squared is always a positive, so you get 1 times negative 2.
Negative 2.
Negative 2 minus 1.
Negative 3.
Good, so we have the order pair 4, negative 3. So we go to 4 and to negative 3. Ooh, well that tells me that if that's that, I can reflect that point. That means I also get 6, negative 3. It's like 2 for 1, man. 6, negative 3. Not only do you have the mirror here on your graph, you have the mirror here in your, for the y's here in your table. Okay, so now let's calculate what point now?
3.
Let's go with 3. Okay, so negative 2, 3 minus 5 squared minus 1. 3 minus 5 squared is?
Negative 2. Oh,
Neg-
1.
Negative 2 squared?
Oh, 4.
4 times negative 2
Negative 8.
minus 1?
Negative 7. Or
Neg-
negative 9.
Negative 9er. Okay? So 3, negative 9er goes here. Reflected, it's 2 units away, so go 2 units this way. That gives me 7, negative 9er. Okay? And now we can draw our parabola. Any questions up to there? When you're being an amazing parabola drawer, okay, you need to start at the vertex and always go horizontally first. So go out side to side first. So I'm going to cruise this way a little and then go down. And I find it helpful if I look at the next point as I'm going towards it. So I'm going to go out and then go downward. And even though I do that, I'm still not always perfect at it. I'm far from perfect at it. As you notice right there, that's really bad. Okay, that's why you use a pencil for this part, as you should always. Okay, so there we go. We got our parabola. Notice I have a cup here, or an upside down cup. Okay, rather than having a V shape there. Important piece. Have to have 5 points. We got them. Amazing fun, right? Any questions on it? How many of you were here this summer? Now, we did some shortcuts this summer that'll help you out tons. How many remember the shortcuts? How many have your notes from this summer? Dude, you should have those notes. You should bring them with you every day this chapter. I promise you they'll help. For those of you who don't have them or weren't here or you sold them on eBay for a lot of money, good job. Make some money. But now you don't have your notes anymore. Okay. Let's try.
Everybody's best friend.
Let's try some other problems. Now, take a look at your assignment you picked up on the way in. Let me explain what you're going to do today. Eli, Nick, and Cody, later you're going to have to grade your assignments. Maybe tomorrow. You'll have time tomorrow. Okay, we're going to cross out number 20. We're not doing that. We are going to do the example side, everything else. Okay, I will tell you that one of the toughest problems on here is number 10. Okay, so challenge yourself. I probably won't have time to help you with it, so it'll be kind of like an extra credit piece today. Okay, notice numbers 1 through 4. It says each point lie on a parabola that has a vertex at the origin. Write the equation. Do you have to graph these? Do you have to graph these?
Yeah.
No. Why? Because it doesn't say graph, right? Okay. Example 2. Write the equation of each parabola. Do you have to graph these? No, dude. In fact, they're graphed for you. Okay. Example 3. Sketch each parabola. Label the vertex and axis of symmetry. Do you have to graph these? Yes. Sketch the parabola. In fact, I want you to graph. It's not a sketch. You are graphing exact points. Okay, you're going to label the vertex and axis of symmetry. Notice how many there are. How many? 9. Now, you have a piece of graph paper that I gave you on the way in, and some of you are type A'ers, kind of like me. And so what you would do, as I'm about to graph some of these with you, some of you would freak out when I say, hey, we're going to start on number 15 as a class. You're like, what about 11, 12, 13, 14? Well, 11, 12, 13, 14, 15. Now we can start. Okay? So those of you who have to have them pre-numbered, then pre-number it. All right. Yes?
Why do you mess up your number? Never mind.
Okay. No, I need to use my pencil. Sorry, man. That's why I have it. You can use one on my desk if you like. All right, number 15. We're going to zoom in here. What's the first thing you should always do when you're graphing? Jody? Yeah, put in the vertex and axis of symmetry. Those of you who got this cool sheet on the way in, if you turn it over magically, well, not too magically, but because of the copy machine, you have this note page on the back, and it actually tells you, it says identify, or graphing quadratics, identify and plot your vertex. The HK. Note, H equals the opposite of B over 2A. And you're like, well, why do I even need that? Can I just look at it and say H is 1? Because it makes that 0? Yeah, you could. However, life doesn't end on the example side of your worksheet. Tomorrow, when you go to the mix side, is everything in vertex form?
Yeah. No.
No, which ones aren't?
19 through 24.
Yeah, 19 through 24. Those are in standard form. In order to get them to vertex form, or at least to find the H, you need to use opposite of B over 2A. That'll be for tomorrow, though. So we'll skip that for today because everything today is in vertex form. All right. Next, dash in the axis of symmetry, x equals h. So find HK, then dash in the axis of symmetry. Let's pause right there and do that on this problem. So tell your neighbor what HK is and what the axis of symmetry is.
Did I miss anything?
You got it right now. As long as you're with us on this, you'll be good. Okay, vertex is?
1, 2.
Vertex is whatever makes this 0, that's our H. So in that case, it's 1. And our K is always back here, which is 2. The order pair 1, 2. And X equals, this is AOS, right? Axis of symmetry, X equals 1. So what we're going to do is we're going to plot 1, 2. 1, 2, right there. And we've got axis of symmetry. Is this going to open up or down? Up. Now, when I label my point, I like to know if it's going to open up or down so I know where to put my point. So it's 1, 2. It's opening up because A is positive. In fact, A is 1 in this, right? Okay. And my axis of symmetry, we're going to label it by saying x equals 1. All right. How many are with me? All right. It's amazing. Okay. Now, if we go back to our cool notes, step 3 says find 2 other coordinates by completing a table of values. And remember, some of you were using this one with me a minute ago where we put the rule here. We put y here. Okay. If you're here this summer, we talked about patterns. We said if you start at your vertex, now pay close attention, those of you that zone out and you're zoning right now and you can't quit zoning, your neighbor's hitting you or something, okay? If you find your vertex, go to your vertex, identify your A in your equation. From your vertex, if you go over this much and you go up this much and multiply it by A, up this much times A, you'll be at your next point. If you go over 2 and up 4A, you'll be at the next point. Going back to your vertex, go over 3 and up 9A, you're at the next point. Now, the key is understanding that the amount you're going up is always, these are always perfect squares. So the next number would be what?
525.
25 and 36, with the exception that you have to multiply this thing by whatever A is, your accelerator, right? So you have to keep multiplying by A. So it's whatever this number is, 5 squared is 25, and then A. If you're going over 6, you have to square that, 36, and go up or down A. Okay, 36 times A. Multiplying those things together. So in this case, what's A? 1. So really, I'm just counting by perfect squares if it's 1, right? Because if I go over 1 and up 1 times A, well, 1 times 1 is 1. And then I go back to the vertex. I go over 2 and up 4 times A, or in this case, just 4. Okay? How many are with me on that? Okay, that's the patterns way. Okay, so from there, what we can do with these points, how do we find 2 more points? Yeah, just reflect it. This just goes here, 1 unit away. This one is 2 units away, so it's over here. And then we graph them. Okay, I always go with the first 3, kind of try to draw that U shape. I try to do that, and then finish it off. It makes it a little easier. Now, if I were you, at that point, I would stop. Questions on that, Cassie?
Do we have to have a table of values?
Nope. No, I don't need to see a table of values if you're using patterns. Okay? Guys, the patterns are a quick way if you understand what you're doing. Now, some students, they get all yippity-skippity here. They're like, woohoo, I'm done. Yeah. And they go, all right. Okay? Don't get so excited because you just missed the problem, because you crossed this line. Or excuse me, you crossed this 4. When x is 4, y is not 7.5. You're wrong, dude. When x is 4, y is actually 11. Even if you go up like this and you're like, yeah. Okay, that's still wrong. Okay? If you are not going to calculate what y is when x is 4, then get to this point and stop. Do not cross this line. Okay? I will be really picky on that. Any questions there? All right. Yeah.
Wait, but one time when we were doing the graph paper, we had to turn in. I did a mini one that big, and you wrote mini graph.
Yeah, mini-me graph. That means I want you to, when we did our actual portfolio pages, I want you to fill the graph on the portfolio pages, which we'll talk about, but you still have to calculate the points.
So
You can't.
do that on here?
No, on here you just stop. I need 5 points on this. So we got 5 with our vertex. Want everyone to try number 11. I don't expect you to be done quite yet, but I want to make sure everyone's got the vertex. It's whatever makes this 0. So h is 2, because that makes that part 0. And k is -4. Okay, and the axis of symmetry is always our x value, so x equals 2. Okay, so we go to 2 and -4. This one's opening upward, so that means when I label my vertex, I can put it underneath there. Got my dashed, pretty dashing. X equals 2. How many made it that far? Yeah, Mano. Any questions up to there? Okay, this is where it gets a little tougher for some of you. Okay, what's our A term? 3. So when I go over 1, I'm not going up 1 this time. I'm going over 1 and up 1 times 3. Or over 1 up 3. In fact, this is the amount, that whatever A is when in vertex form, that's how much you always go up the first time. Right? Okay, so over 1 up 3. Over 2, not up 4 now. It's 4 times 3. So over 2 up 4 times 3, or 12, which is, brings me all the way up to 8. Nothing else is going to fit. So I'm going to reflect that. And I'm going to reflect that. And as Eli was just pointing out to me, this is kind of a narrow graph. So it almost looks like it comes down like a absolute value, but you want to make sure that you get that rounded bottom on there. Okay, down here. Make sure that's rounded. All right. Pretty neato, man. Cassie?
Okay, so for the pattern thing, how did you get that?
Remember, the pattern you're doing is from your vertex, you're going over that much and up the square of that number. So over 1 up 1 squared, which is 1. Over 2 up 2 squared, which is 4. Over 3 up 3 squared, which is 9. However, if there's an A value, you've got to multiply it by that A value. So in this case, A is 3. So we're going to go over 1 and up 1 times 3. Over 2 and up 4 times 3, which is 12. So we got to multiply it by that accelerator. Any other questions? Ethan? Yeah, like number 12? Yeah, good job, man. Nice. Yeah. Well, let's figure out the vertex. What's the vertex here? -6, 5. Okay, axis of symmetry.
5.
X equals.
-6.
Okay, so we go down to -6 and up to 5 right there. Is this opening up or down? Down, so I'll label it above. -6, 5. Okay, we have axis of symmetry at x equals -6. Okay, so as Ethan's question, what happens when you have that fraction? Well, I will tell you you need 5 points. And if A is 1/3, if that's a fraction, I'm dividing by 3. That's what that denominator does. It's a division. So I'm looking at this and I'm figuring out which one of these are divisible by 3. 9, right? And 6. Okay, now I don't know that 6 is going to work, but 9, let's try 9 first. Okay, so if I go over 3, I'm going to go down 9 times 1/3. Well, what's a third of 9? 3. So I'm going to go over 3 and down 3. Now, as you can see, I'm out of room over there, right? So I've got my other point here. I can't even, like Jordan was pointing out, well, 36 is divisible by 3 also, but I can't go over 6. Yeah?
Can't you just use the -1/3?
Yeah, I could. I could just go over 1 and down 1/3. I mean, that's probably what I would do in this case. Just go over 1 and down 1/3. And then have that other point. And then, once again, don't get all yippity-skippity with it at this point. You better stop, right? Don't cross that -2 line. But notice it's really wide because you have a fraction. Right? It's closer to 0. So that graph's really wide. Those should be your quick visual checks. Eli?
So, like on 14, how would you How would it be 4 or -4 for h?
-4, because that makes that 0.
Okay.
Okay, need everyone to take a look at number 1. We're going back now. Number 1. Number 1 says each point lies on a parabola that has a given vertex at the origin. Well, if the vertex is at the origin, vertex is HK. If that's at the origin, what is HK?
0, 0.
Yeah, 0, 0. Okay, each point lies on a parabola vertex at the origin. Write the equation for the parabola. Well, that, in other words, what they're saying is if I have this graph, my graph starts here and it goes through the ordered pair 4, 3. Okay, it goes through this point A. So I have a parabola that looks something like this, at least half of it. And then it's reflected over here, right? We want to know the equation to that parabola. Well, they tell us HK. They tell us XY. The only thing they don't give us is A. Now, this A is not that A. It's probably a poor thing for them to put there. X minus H squared plus K. We could find A, though, by using HK and XY. If I put 3 in for Y, for X, 0 in for H, and 0 in for K, I now have 3 equals 4 minus 0 is 4 squared, or
16.
16A plus nothing. What is A?
16/30.
It's almost
3/16.
3/16. I mean, why wouldn't it be 3/16, right? 3/16. It's kind of weird, but that's A. They're asking for the equation, though, so we got to finish it up. Y equals A times X minus H, which is 0, squared plus K, which is 0. That simplifies to Y equals 3/16 X squared. That's the answer there. That's how we write our equation. Guys, one last thing you have today. Example 2, take a look at it. Write the equation for the parabola. In fact, I want to look at 9. In order to write an equation, you need to know X, or you need to know H and K and A. We know HK. HK is 2, 4. That's easy. We need to know A. Right? That became that. That became that. A is, just remember, if you go over 1, it's how much you go up or down to get to the next point when you go over 1. So in this case, what's A?
-1/30.
It's 3. You're going over 1 and down 3. That's A. That's your equation. It's that simple. I will tell you the hardest problem on here, though, is number 10. Little extra credit for it. Any questions?